Okay, everybody, we are about to do the chi-squared test of independence. I strongly recommend that you watch the previous video, the introduction to chi-squared, all 4 parts so you can see how these are connected. This is going to be a more elaborate problem, so buckle up because we've got a lot to talk about here. Now, I have a table here, and we have a table that expresses 2 different types of categories. See, this table has 21-year-olds and how much volunteer time they spent each month. I broke my 21-year-olds into 3 categories. I broke them into the type of schooling they were getting at that time. So one type was students who went to a university, and another type are students who went to a community college, and the last type are students who didn't go to either of those. Now, I also asked, how many hours a month do you volunteer? And we got and I didn't take any responses from those who didn't do any volunteering, so we're just looking at those who do volunteer. And again, we have those who did 1 to 3 hours, 4 to 6 hours, and 7 to 9 hours. Now, how many rows of data do we have? Now, a row goes horizontally. And if you count the rows from top to bottom, we have 1, 2, 3, 4. But we really only have 3 rows of data. Row 1 and row 2 and row 3. These 3 rows have data in them. And I consider a row with data in it to have numbers that were measured. How many columns of data? Now, a column is vertical. So you see we have 1, 2, 3, 4 columns of data, or columns just in total, but I consider these 3 columns here as columns of data. And again, columns of data, columns that have numbers in them, okay, that we have measured. Now, what category would we associate with our rows? So it looks like our rows have university students, community college students, and not enrolled students. So what we have is we have education choices. So student, education, choices. So the rows associate with the type of education choices the 21-year-old has. Now, what category would we associate with these columns? The 1 to 3, the 4 to 6, the 7 to 9. That would be the number of volunteer hours each student is doing per month. Okay, now it's important to get these set up because we're going to need that for the test of independence. Now you're probably wondering, what is a test of independence? A test of independence is to see if the rows and the columns are related or not related. Like, are they independent of each other or are they dependent on each other? So we're really trying to hone in on whether the type of education the student is getting is having an effect on the number of hours that they are helping and volunteering. You know, does a community college student volunteer more than a university student? Does a not enrolled student volunteer more, or than a community college student? Because this test of independence is going to say whether this affects this. Okay, so let's get down what we just talked about. Let's summarize it. So here's the question: is the number of volunteer hours related to the types of education choices? And that's what we're really doing here. Okay? So, this is another, well, let me let you see that here. This is another right-tailed problem. The null and alternative hypothesis have a pretty good pattern as well. So, I'm going to write down for the null and alternative hypothesis the format that you will use for these problems. Is the column title is the column title independent of the row title. So basically, the null hypothesis, and I shouldn't probably phrase that as a question, I'm going to phrase it as a statement. The column title is independent of the row title. And for the alternative hypothesis, you would say the column title is dependent on the row title. So they have a relationship. Now, we're not actually going to say like which one's better, which ones are worse. All we're trying to do is test to see if one is independent of the other, which means that it doesn't matter how much education you're getting. The type of education is not affecting your volunteer hours. So we have this formula. Now this formula looks pretty familiar, right? Observed minus expected squared divided by expected. Now you did this on the last kind of problem, the goodness of fit tests that we did. But this is going to be a little bit more complicated because I is going to stand for, in J, what we have is we have our row and column indicator. We're also going to have a little bit more elaborate degrees of freedom, because degrees of freedom are going to be the number of rows minus 1 and also the number of columns minus 1. Okay, so you multiply those two together. So rows minus 1 times columns minus 1. And a little side note, each cell has to have at least 5 responders in it. I call that the Family Feud rule, where you just can't have one category that doesn't, or one cell in your chart have less than 5 people that said that they do that amount. Okay, so buckle in, everybody. This is going to be a challenging problem here, and I want you to kind of follow this along methodically, because to do a test of independence, we not only need our data that we have here in the center of our chart, which I will highlight as blue, okay? We not only need this data, but we also need the totals. So on the second page of this handout, or this part of the handout, I've expanded my tables a little bit. Now it says first we need totals of your 3x3 matrix. Now a matrix is an array of numbers, and an array of numbers that's generally given by rows and columns. Any math book worth its salt will be giving you matrices in terms of rows by columns. But what we're doing is we're expanding this 3x3 matrix that had 3 rows of data and 3 columns of data, and we're going to add a 4th row and column of data that's going to be a row total. Now, we're adding this to the mix, and if this isn't given to you, you're going to have to do this yourself. So you're going to add 96, 133, and 61. And this row total is going to be the sum across this row, and that is going to be 290. And I add 111 to 96 to 48, and that's 255. 91, 150, and 53, and that's 294. And this is going to take a little time, but I am going to change color a little bit when I go to a new type of sum. So here's a column total. 96, 111, and 91, 298. 133, 96, 150, 379, And this is just, again, adding straight down to get our column total. Then we get to 61, 48, 53, the most hours volunteered per month, which has the smallest total, which is not unexpected. Now, to get my total, because this was the column total, this is my row total, let's get our grand total. So this right here, I could add these 3 red numbers or these 3 green numbers, and this gets me to a total of the entire table of 839. So this here is my grand total, or table, the entire table sum would be the 839. This is like a 2-part process. We've got the observed minus expected divided by expected, and we know our observed by looking at all of these numbers here. The yellow numbers here are the observed, okay? Yellow is observed, so we're going to mark that as yellow right there. Now, expected is going to be what we find in this table, and we have to use the expected equation here of row total, column total, and total in all table. And that will give us this brand new table down here. And let me methodically go through this with you, because this is going to take a little bit of time. So what we need is the row total and the column total divided by the total in all table. So the row total for this cell right here is 290. So 290. The column total here of this cell, the 96, is 298. 298. Now, the grand total is going to be 839. And if I multiply these two and divide by 839, I get 130.00. That is my expected value of the university students. So we got 96, but I really expected 130. Okay, now I'm going to do the next one. This is 133, so it's in the row of 290. This is in the second column, so that column total is 379. And then we're going to do the sum. That's 839 again, so 839. We multiply these two, divide by 839, and we get 131.00. So that one was pretty close. We expected 131, we got 133. So again, we're figuring out this expected column here. Okay, on to the next one. We're going to have 290, and then we're going to have times 162, and then we're going to divide by 839. Okay, we do our multiplication, 260 times 162, and divide by 839, and we get an answer of 56.00. Alright, there we go. There we have our expected values, and that one was pretty close. Look, 61 versus 56. That first one, though, really got me worried, because 96 and 130 are not close together. So our observed and expected is now done, and we have to do this for the community college row and the not enrolled row. So do you see something that's a pattern in these? Well, so far you'll notice that each of these is divided by 839. So if I do that, I can actually make this process go just slightly faster, because I'm always dividing by 839. Which means you're going to want to make sure that your your sums are correct here. You may want to add across the green and add down from the red to make sure that's the correct number. Okay, so now I'm going to be in the second row of community college data here. So this is going to be 255. Now, since I'm basically pulling from the second row here, all of these numbers will be the same, because that's going to be the row value at that row total at that row. Then what I can do is I can take my numbers here along the bottom, the 298, the 397, and the 162, and you can see I can just drop them here and And so this goes a little bit faster if I just kind of take it as rows and columns. And now I'm ready for the total after I've multiplied this out. This times this divided by this is 90.57. This times this divided by this is 115.19. This times this divided by this is 49.42. Now what you might want to do is you might want to pause the video right here and try filling in this last row yourself and check to see if you get the same values I do. Okay, so following the pattern I did before, this is 839, 839, 839. I think if you have colored pens, this would make this a little bit easier too. A little bit easier for you to keep track of, right? Okay, so now I'm going to go to my red pen because my row sum on this is 294 all the way across. 294, 294, and 294. Now, in terms of my column totals, 298, you see how all these are 298? And 379, 379's for all those, and 162. Just a lot of typing, but again, it's least methodical. You can kind of feel yourself getting into a rhythm, feel good because you are doing, you're doing the correct work. I always find that in math I feel good if I'm on the right track and getting the same answer as what's right. So here are my three values: 104.42, 132.81, and 56 and 77 hundredths. So here's what we found. We have found the yellow as our observed data. Now what I'm highlighting in blue is my expected data. Okay? So now I have my yellow observed, my blue expected, and again I'm going to keep that color coding consistent. So now I take my yellow value up here, the 96, subtract my 130, square it, and divide by 130. So let's write down all of the observed values first. 96, okay, that was that cell's value of observed. 96, 133, 61. Then we have 111, 96. Whoops, my little stick there didn't show up. There we go. And 48. 91. 150. Make sure that shows up. And 53. Okay. Now what I'm going to do is I'm going to write down my blue expected values here. Now we're not only going to subtract the blue expected values, we're going to square them and divide by them again. So this is going to be divided by, or subtracting 131, quantity squared, divided by 131. And this is going to be subtract 56, quantity squared, divided by 56. This is going to be subtract 90.57, quantity squared, divided by 90.57. And this is subtracting 115.19. Pretty big difference there. And then we're going to divide by 115.19. Woo! Bet you never had a problem this long before. 48 minus 49.42, quantity squared, divided by 49.42. Now that was pretty close. It was good job there. 91 minus 104.42, quantity squared, divided by 104.42, and then subtract 132.81, quantity squared, divided by 132.81. Okay, now we're just getting done with writing these down. 53 minus 56.77, quantity squared, divided by 56.77. Holy smokes, right? That's a lot. And I feel ya. This is just part of the work that we're doing here. And I'm going to switch to a gray pen, because if I go 96 minus 130 squared, then divided by 130, I get an answer of 0.476. Now that's small. That's good. That means we were pretty good on that. because what's going to happen is we're going to keep adding these, we're going to add all these up for our chi-squared test statistic. So subtract these and subtract these, square it, divide by 131. This is another small value, which is good. We were pretty close there. And here we go, 61 minus 56 squared divided by 56. That gives us 0.446. Okay, so pretty close on these, but now as we get to these, you're going to see some bigger jumps here, because this minus this squared divided by 90.57 is 4.608. Oh boy, that's big. That's not great. So 96 minus 115.19 squared divided by 115.19. This is going to be another big number, 3.197. And then 48 minus 49.42 squared, then divided by 49.42. This is actually good because it was pretty close at 0.031. Now what I would do is pause the video and see if you can get this last row here by yourself. And that way you can check to see if you're doing it right. Okay, so we subtract those two, square them, we get 1.725. That's another kind of big number here. Subtract these two, square it, divide by 132.81, we get 2.225. That's a big number. 53 minus 56.77 squared divided by 56.77, this gives us 0.25. That's a small number. And if you're curious what I mean by big or small, I mean, if this was a completely independent thing, we should have zeros in all of these columns because our observed match the expected. But you're seeing that we don't get zeros. So what we have to do is we have to add up all of these boxes. So you see what I'm circling in the formula there? That's the sum of all 9 cells. And so we add up the 0.476, the 0.031, the 0.446, the 4.608, the 3.191, the 0.031 again, plus the last 3, the 1.725, plus the 2.225, plus the 0.25. If we add up all of these numbers, what we get is we get our answer of 12.99, or 13, depending if you just want to round it. This is your test statistic. Chi-squared is 12.99. Now we need our degrees of freedom. Now, what we're going to do is look at the rows and columns of data, not the total columns. So we had 3 columns, and then, or sorry, let me color code this. We had 3 rows, and then we had 3 columns, okay? Which means this is 2 times 2, and 2 times 2 makes a total of 4. And now what we're going to do is use the CDF on the calculator. So we're going to, the chi-squared CDF. So we're going to hit second key, then we're going to hit the vars key, okay? And then we're going to type in our low number, which is our test statistic of 12.99. Our high number is going to be infinity, which is 10 to the 99th power. And our degrees of freedom is going to be equal to 4. And what this is going to give us is going to give us our p-value. So let's get our calculator out. I know you've had it out already, but let's get the calculator to show you how to type this in. Click the calculator on, because I'm sure it may have fallen asleep during this long note session. Click the second key and the vars key. Scroll on down to the chi-squared CDF and hit enter. And the lower number is going to be 12.99 because we want to right tail test to infinity, 10 caret 99, and our degrees of freedom in this case is 4. And let's check out our p-value. Our p-value is 0.11 or 0.0113 or 1.13%. So our p-value is equal to 0.0113. Now, you'll notice that we have to make a conclusion based on this, and this is based on the alpha given in the problem. Oh, you notice there is no alpha given in the problem, so we default to an alpha of 5%. So if we look at the p-value of 0.013 and the alpha of 0.05, since the p-value is less than alpha, we have sufficient evidence to reject the null hypothesis. EVIDNCE, to reject the null hypothesis. Wow. It's kind of funny when I do this in class. I usually say, "What's your conclusion?" And then somebody invariably says, "My conclusion is I'm going to drop the class." Because after doing a problem like this, I mean, look how involved it was. You might feel, oh, there's no way I can possibly do this well or accurately for a test. Oh, but just you wait. The next video I'm going to show you is how to let the calc take this heavy lifting off of our shoulder. It will mean that we have to learn about entering matrices in on the calculator, but after you've done this page, I guarantee you are going to want to do matrix work on the calculator over all of these calculations, because you could make a simple mistake and really flub your answer, because this p-value at 1%, I mean, what if our alpha was 1%? Well, shoot, you don't want to make any mistakes. So stay tuned to the next informative video as I show you how to do this entire process using matrices on the calculator.